Hello students, today's topic is Ohm's Law. In the year 1827, scientist George Simon Ohm, he has conducted an experiment by taking the battery connected with the ammeter, and this ammeter is connected to a conductor having the resistance R, and this resistor is connected with the voltmeter, and this one, a negative terminal of the battery is connected to a plug key. Now from the plug key, he has connected to a rheostat, that is the variable resistance, which gives the variable resistance, rheostat. And from the rheostat, it is connected to the conductor and the voltmeter. So he has made a experimental setup like this. So initially he has taken a single cell. Here total 4 cells are there. Initially he has taken a single cell. After taking a single cell, he has made a observation in the ammeter and the voltmeter. So when the potential difference is 0, there is no potential difference in the circuit, means the current is also 0. He has taken one single cell having the potential difference 2 volt. Fine. After that, he has measured the current. He observed that the current in the ammeter showing that the current is 1 ampere. Next, he has taken one more cell. He has added one more cell in the circuit. So the potential difference is 4 volt, and measure the current in the ammeter. This time the current is 2 ampere. Similarly, he has added one more cell. Third one cell he has taken. Now the potential difference is 6 volt and the current is 3 ampere. Current is 3 ampere. Now he has added one more cell. This time the current is 4 ampere. Now look at these values. That the voltage and the current. As the voltage is increasing, the current is also increases. Fine. By looking into the observation of these values, the George Simon Ohm has made a statement, has made a law. That law is a very famous law called as Ohm's Law. So, according to the Ohm's Law, the statement for the Ohm's Law that the potential difference across the ends of a conductor is directly proportional to the current flowing through it. However, the temperature, pressure, etc. The other physical conditions remains constant. So this is the statement for the Ohm's law. Look at here. The statement. What the statement? The potential difference across the ends of a conductor. So the conductor is here. Fine. Whatever the potential difference across the ends of the conductor is there, that is the potential difference is V. Fine. This potential difference is directly proportional to the current flowing through it. Whatever the amount of current is flowing through it, it is directly proportional to the current. Fine. Because as the voltage, the potential difference is increasing, the current is also increasing. So that is the meaning of, that is V is directly proportional to I. And here the other physical condition like temperature and the pressure, it should be constant. So there should be no change in the temperature and the pressure. If we have changed this, V is directly proportional to I, it does not hold good. So we need to be keep in the mind, that is the temperature and the other physical condition, it should be constant. Now V is equal to R into I. Whenever we will remove the proportionality sign, we will take the constant, and here the constant is R. This R, it is resistance. It is called as resistance. So resistance, it is proportionality constant. Okay. Now this resistance R, it is equal to V by I. R is equal to V by I. So resistance, it is the ratio of V by I. We have the one more expression, V is equal to R into I. Now let I define the term resistance. What do you mean by the resistance? Now here one example I will give in our day-to-day life we will experience. Let us suppose that we are at the open place. Okay, we are at the open place and there is a strong wind is blowing towards you. Okay, so here when the strong wind is blowing towards you, it is difficult to move. It is difficult to move towards the in the direction of, that is opposite to the wind. Fine. So here what will happen, that when the strong wind is blowing towards you, you are unable to move in the forward direction. Fine. Are you getting this? So here that wind is going to be opposes to move you. Fine. So that is the resistance. That is the resistance for you. So in the same manner, when the current is flowing through the conductor, in the same manner, when the current is flowing in the conductor, this conductor opposes the current to flow through it. That property of the conductor we have given the name called as resistance. So definition for resistance. Definition for resistance. Resistance. It is the property. It is the property of a conductor that resists the flow of current is called as the resistance of a conductor. Here the resistance and the current, these two are inversely proportional to each other. These two are inversely proportional to each other. The meaning of inversely proportional to each other means if one quantity increases, the other quantity decreases. Got it? Or if one quantity increases, this quantity increases, this quantity should decrease. So that is the meaning of inversely proportional to each other. Here R and the I are inversely proportional to each other. Whereas you see here V and I, these are directly proportional to each other. Which means when V increases, I also increases. Or V decreases, I also decreases. Got it? Now, the very important thing we need to be remember between the R and the I, when resistance is doubled, this current will become half. Very important. We need to be remember. When the resistance of the conductor, if we have doubled, the current flowing through it, it is equal to half. Got it? This one point, a very important point, we need to be remember. Okay. Now the SI unit for the resistance. The SI unit for the resistance is ohm. The unit for the resistance is ohm, which is represented by the symbol, the Greek letter omega. It is the Greek letter omega. Got it? Now let me define the 1 ohm resistance. So when we will say the resistance of the conductor is 1 ohm. So when we will say that one. So here, in order to define that one, you look at the formula carefully, you will get the idea that when we will say the resistance of the conductor is 1 ohm. So the 1 ohm resistance. What is the formula for the resistance? R is equal to V by I. Unit for the resistance is ohm. So we wanted to define 1 ohm. We wanted to define 1 ohm. So here this is 1 volt and the current is 1 ampere. So any conductor is there, that conductor resistance is 1 ohm. We wanted to say the resistance of the conductor is 1 ohm, means the potential difference across the ends of that one conductor is 1 volt and the current should flow through it is 1 ampere. Let's suppose that this is one resistor, okay, having the resistance R. Now the potential difference across the ends of this one resistance is how much? It is 1 volt and the current flowing through it is 1 ampere. Got it? Then we will say the resistance of this one conductor is 1 ohm. A very important question in the examination. They will ask, define 1 ohm. So here resistance of a conductor is said to be 1 ohm, is said to be 1 ohm when the potential difference is how much? Potential difference is 1 volt and the current flowing through it is 1 ampere. Then we will say the resistance of the conductor is 1 ohm. Got it? Fine. Now these things related to the resistance. Now come to the thing that the relation between the V and I. Here, when we will plot the graph by using the values that V versus I, we wanted to plot the graph by using those observations. After plotting the graph, you will get the nature of the graph is a straight line. This straight line indicates that these two quantities, that is voltage and the current, these two quantities are directly proportional to each other. When the nature of the graph is straight line. When it is straight line, we will say that the given quantities are directly proportional to each other. Okay. Now randomly I will take the values here in order to explain the other terms. So let's suppose that the points here when current is something, voltage is something like this. We will get accurate values we will get when we will do the experiment. Now roughly we will understand. Now let's suppose that I have considered this point on the straight line. We will call this one straight line as slope also. Okay, I will use the word slope also. So here this line indicates the potential difference. This is potential difference and this will be the current. Okay, now if we have done R is equal to V by I. If you have done V by I, you will get resistance. Fine. You will get the resistance. According to the formula, look at here. R is equal to, it is the ratio of voltage to the current. So if we have calculated, you will get the resistance. Now if I taken this one point, this is V and this is I. Fine. Now if we have calculated V by I for this point, you will get the same value as you got the value for this point. Got it? So which means whichever the point you will consider, the value of the resistance is same. This one point we need to be remember. Okay, so in the examination they will ask the question. Now let's suppose that we have the one more conductor, we have one more resistor, and we have plotted the graph for the other that resistor, and we got the same nature of the graph. That graph also I will draw in this one only. This is the conductor 1 and this is the conductor 2. Fine. Now for the conductor 2, let's suppose that if I have consider this one point on the conductor, second one conductor, this is V, fine, this is V and this is I, this is V and this is I. I will keep the thing that I and this one I as same, constant I will keep. Now you look at here, this V and this V. This V for the conductor 1 and this V for the conductor 2. Got it? Once again, this V, it is for the conductor 1 and this V will be the for the conductor second one. Now compared to these two things, the potential difference, that is the voltage for the second one conductor is highest. Fine. Look at here. Compared to this one is just highest is there. Now look at this formula. If the voltage increases, the value increases, means obviously the resistance also increases. Fine. Obviously the resistance also increases. So here we got one idea that which is the resistance which is having the highest slope. Got the resistance which is having the highest slope, that resistance is having greater resistor. That resistor is having the greater resistance. So here in between these two conductor, R2 is having the greater resistance. Got it? R2 is having the greater resistance. Just I will make separate for easy understanding purpose. In the examination, how they will ask the question. Here is the first conductor, here is the second conductor. In between these two conductor, which is having the highest resistance. So our technique is what? Which resistor is having the highest slope? So here the second one conductor is having the highest slope, which means this second conductor is having the highest resistance. Got it? So many times this type of question came in the examination. So keep it in mind. But let's suppose that the graph is I versus V. And the same question, two conductor they have given. Conductor 1 and the conductor 2. conductor 1 and the conductor 2 they have given. And they have asked the same question, that in between these two conductors, which is having the highest resistance. So what we have memorized the thing, which is having the greater resistance, that will be having the greater, which is having the greater slope, that is having the greater resistance. But here V and I, they have changed. It is V by I, but here it is I versus V is there. In this one situation, which is having the lowest slope, that resistance is having the greater resistance. Once again, in this one case, that is I versus V, in this one situation, in this one condition, which slope is having the lowest slope, that slope is having the greater resistance. So here R1 is having the greater resistance than R2. Got it? So this one and this one are very important questions we need to be remember for the examination point of view. Okay, so this is also one expression. Remember this one. This is also the expression. We need to be remember this one carefully. Fine. Now this Ohm's law, note you need to be take down this. This Ohm's law, it is applicable for the conductors only, not for the semiconductors. Semiconductors. Fine. A very important question. The Ohm's law not applicable for the semiconductor. It is only applicable for the conductors. Okay. So this is all about the Ohm's law. Thank you.